Good morning, students. This is Murthy sir. In the last class, we discussed about VSCPR theory. Today, we will learn about valence bond theory proposed by Linus Pauling. Linus Pauling proposed valence bond theory based on quantum mechanical model of atom. So this is further advancement of VSCPR theory. A view of chemical bonding in which bonds arise from the overlap of atomic orbitals on two atoms to give a bonding orbital of electrons localized between the bonded atoms. For the proposal of this valence bond theory and hybridization concept, Linus Pauling was awarded Nobel Prize in the year 1954. Valence bond theory considers that the overlapping of atomic orbitals of the participating atoms form a chemical bond. Because of the overlapping, it is most probable that electrons should be in the bond region. Students, greater the overlapping of the orbitals that form the bond, the stronger will be the bond. Based on the pattern of overlapping, there are two types of covalent bonds, sigma bond and a pi bond. The covalent bond formed by sidewise overlapping of atomic orbitals is known as pi bond, whereas the bond formed by overlapping of atomic orbitals along the internuclear axis is known as sigma bond. Students, sigma bond is stronger than pi bond. Students, the reason is, in case of sigma bond, the electron pair shared is concentrated more between the two nuclei due to end-to-end or head-on overlap and attracted to both the nuclei. That's why it is more stronger than pi bond. Students, here you can observe the presence of a sigma bond between two hydrogen atoms in hydrogen molecule. So here the overlapping of two s orbitals in hydrogen molecule. Students, pi bond is formed by the lateral overlap or sidewise overlap of p orbitals. This is weaker than sigma bond. Students, if you take oxygen molecule, between two oxygen atoms, double bond is present. If you take nitrogen molecule, between two nitrogen atoms, triple bond is present. In case of double bond and triple bond, each first bond between two atoms is a sigma bond. All second and third bonds between two atoms are pi bonds. Sigma bonds are significantly stronger than pi bonds. This is because sigma bonds allow for electron density to be concentrated to a much larger degree between the two nuclei. It happens on internuclear axis. Students, the pi bond overlap gives a weaker bond due to the lateral overlap of p orbitals, which is not to greater extent. Students, now let us see different practical examples. The first one is hydrogen molecule, how the s orbitals are overlapping and forming a sigma bond. Here you can see the electronic configuration of hydrogen atom in the ground state is 1s1. In the formation of hydrogen molecule, two half-filled 1s orbitals of hydrogen atoms overlap along the internuclear axis, forming a sigma bond. Students, now let us see the overlapping of p orbitals in chlorine molecule Cl2. The electronic configuration of chlorine atom in the ground state is 1s2, 2s2, 2p6, 3s2, 3p5. The two half-filled 3pz atomic orbitals of two chlorine atoms overlap along the internuclear axis and thus by forming a sigma bond. Here you can see how the overlapping of p orbitals are taking place and how a sigma bond is formed in chlorine molecule. Students, in HCl molecule, hydrogen chloride, polar covalent bond is present. Students, in case of HCl molecule, the half-filled 1s orbital of hydrogen atom overlaps with the half-filled 3pz atomic orbitals of chlorine atom along the internuclear axis to form a sigma bond. Here you can see that. Students, now let us see oxygen molecule. The electronic configuration of oxygen in the ground state is 1s2, 2s2, 2p4. The half-filled 2py orbitals of two oxygen atoms overlap along the internuclear axis and form a sigma bond. The remaining half-filled 2pz orbitals overlap laterally to form a pi bond. Students, in oxygen molecule, there is a double bond between two oxygen atoms. In this double bond, the first bond is sigma bond and the second bond is pi bond. Students, end-to-end or head-on overlap of p orbitals on internuclear axis, that is sigma bond. Sidewise or lateral overlap of p orbitals, that is pi bond. So one sigma bond and one pi bond are there in oxygen molecule. Students, in nitrogen molecule, there is a triple bond between two nitrogen atoms. In this triple bond, the first bond is sigma bond and the remaining two bonds are pi bonds. The ground state electronic configuration of nitrogen atom is 1s2, 2s2, 2p3. A sigma bond is formed between two nitrogen atoms due to overlapping of half-filled 2px atomic orbitals along the internuclear axis. Students, the remaining half-filled 2py and 2pz orbitals form two pi bonds due to lateral overlapping. Thus, a triple bond is formed between two nitrogen atoms. Here you can see end-to-end or head-on overlap of p orbitals and lateral or sidewise overlap of p orbitals forming sigma and pi bonds. One sigma bond and two pi bonds are seen in nitrogen molecule. Students, in the next class we will discuss about hybridization concept.